A lot of people are delving into homeschooling, some people are doing distance learning, and some people are just trying to teach their children a little bit better at home. So whether you're homeschooling, distance learning, or just trying to get a better understanding of science, there are a lot of things you can do at home to learn science even better. The kitchen is a great place to learn science. You have a heat source, or multiple, you have a water source, you also have countertops for workspace, and you have floors that are easy to wipe up if you make a mess. There are a lot of things you can do to learn science at home. Science isn't meant to be a memorization of facts that you just regurgitate onto some test. Science is meant to be done. Science is meant to be a verb. And you'll learn science best by doing it rather than just reading about it. So how do you learn science at home then? Well, there are several steps. First of all, you need to start with a phenomenon. This doesn't have to be something phenomenal or great, it's just something you observe in the world. This phenomenon needs to spark curiosity or wonder, make you wonder why does it do that? It should also address the standards. Different states have different standards. Most science standards align with the NGSS or Next Generation Science Standards. Each state will have its own set of specific standards. Next Generation Science Standards has a lot of different ideas for phenomenon, and if you're looking to align that with your state, what you can do is search for NGSS, your state name, crosswalk. Usually it's labeled with the word crosswalk in it, so you can find how each Next Generation Science Standard, which is the national standard, aligns with your state's specific standards. I'll put some resources in the description to help you figure that out. Another aspect of a good phenomenon is it needs to be something that you can investigate. Observing things is always good, but if you can't investigate it, you're kind of going to get stuck. And again, these phenomena don't have to be something amazing or astounding. You don't have to make something explode, although that's always interesting, fireworks and stuff like that. It just has to be something you observe. A common phenomenon that's been done by YouTube channels like Bozeman Science and other ones is the one with the dry erase marker on the plate. But you just need to have something that you can observe and sparks curiosity and leads to an investigation. One of the key ways you're going to learn science is by investigating it. So you're going to observe something, figure out why you think that's happening, and then investigate it further. You want to design your own investigation. The more of your own investigation you design, the more you'll learn. It's okay if you end up being wrong. It's actually probably good because you'll learn. You'll learn a lot more by making mistakes. Some key things to remember are safety first. So don't heat up sugar and water to super high temperatures and put it in a situation where it could shoot off everywhere, because that will cause really bad burns. The next thing to remember is that you only want to change one aspect of your experiment at a time. Don't go changing a bunch of different things. If you change one thing at a time with each investigation, you can observe the cause and effect relationship. When you're doing scientific investigations, you always want to make sure you're recording your data. The difference between science and screwing around is writing it down. There are lots of ways to record your data. You can use a composition notebook, your typical spiral notebook, some other kind of notebook. You can even record it digitally using some kind of word processing document, like Google Docs, Microsoft Word, or whatever floats your boat, or boats your float. So when we're doing science, like I said, we start with a phenomena. I'm going to start with the phenomena of making slime. I have borax, glue, water in the tap, a bowl, and a spatula. Now, I've made slime before. There are approximately a mole of slime recipes on the internet. For those of you who don't know, a mole is 602 hexillion, so a lot. Now, when I made slime before, I had several things that I wondered. First of all, sometimes you're just told put a certain amount of this liquid in until it reaches the right consistency. You don't always have the exact amounts. So I'm wondering, what's the exact amount? After I make the slime, I might wonder something like, well, what if I replaced one of the ingredients? Or what if I added something else that's not normally in there? But remember, we only want to change one thing at a time. So I'm going to make slime. First, I'm going to take one bottle of glue. Now, whenever you're doing science, you need to make sure you're recording your data. So this is a normal 4-ounce bottle of glue, which is about 118 milliliters. Now, I don't have to add any food coloring, but I want a little bit of a light blue color. So I'm going to add a little drop of food coloring. Mix that into my glue really well. Now, one of the big phenomena I see here is, how can this stuff turn into slime? This is sticky glue, and if I let it dry, it'd be fun to peel off this bowl, but I'm not going to do that. So next what I'm going to do, so I have a little measuring cup here. This is a 1 cup measuring cup, and I'm going to put a 1/2 cup of water in there. Then I'm going to take my borax, and I'm going to add a 1/2 teaspoon of this borax to my water. 1/2 teaspoon is about 2.5 milliliters. And mix it really well. The borax really needs to be dissolved as much as possible. Contact solution is also a good option for this. And you may be wondering, how can saline solution and borax and water have the same effect? But if you look at the ingredients for borax and look at the ingredients for contact solution, they both contain boric acid, which is also used in a lot of roach killers if you're from the south or somewhere that gets big bugs. So that's something to consider, why certain things work as an activator. So I'm going to do a half teaspoon or 2.5 milliliters at a time. So I add some of that. Now all along the way, I want to be writing down my data. So I'm going to write that I have...
How much glue I have? Solution of half cup of water with half teaspoon borax.
And I'm going to keep track of how much I added. So I add half a teaspoon. Like I said, that's about 2.5 milliliters. And it looks like it's not quite ready yet. So I'm going to add another teaspoon, or half teaspoon, sorry, of my borax solution. Now this is looking a lot more slime-like. It's not quite at the slime level, so I'm going to add another half teaspoon. And you can see it's already starting to clump together. Let's add one more. Now it's looking good, but it's still sticking to my hands. So I'm going to add one more. And you can see that now it's reached the consistency I was looking for. It's slime, it's no longer sticking to my hands. I'm able to get all the little pieces that were on my hands before off. The phenomena here is, how do you take school glue, laundry booster, and water and turn it into something so fancy? What's going on? And how can we investigate this further? What other things can we do? So I have my slime, which is really fun to play with. Now I see this and I wonder, could I add something else to it? Could I make slime that has a different consistency, but still is really stretchy and fun to play with? Now there are a lot of different ways I could vary this to see if I can get a different result. So I might see if I can add something to it, see if that would give me the same results, or how would it affect the texture, or I can see if adding something to it would change how much borax solution I needed to use. I think I'm going to add some shaving cream and see if it affects how much borax solution is needed. Just like with my first set of slime, I'm going to use 1 full bottle of glue. Then I'm going to add about a half cup of shaving cream. I ended up doing a little bit more because it's kind of hard to get the ratios right. I also did 1 drop of food coloring, but it ended up being so pale that it's hard to tell that it's actually kind of a bluish color. And then I slowly added the same activator solution that I used before. So half a teaspoon of the same activator solution with borax and water, stirred it, added half teaspoon more, stirred it, so on and so forth, until I got to the consistency where it wasn't sticking to my hand and it stretched and acted like slime. So I was able to compare how much activator solution was needed when I added shaving cream, and it ended up being a good amount less. Here's my preliminary data. So the first experiment, I ended up using 14.8 milliliters of activator solution, and the second time I used 9.9 milliliters. So I used about 2/3 of the original amount of activator because I added the shaving cream, and I had more volume. Next, I would make some qualitative comparisons. So I would compare the fluffy slime on the left to the regular slime on the right and see how they compared. And I would also graph my quantitative data, so the data with numbers. I would compare those two. It's important to compare and contrast both types of slime. So the regular slime is on the right and the fluffy slime is on the left. So I want to note their similarities and their differences. So I'm squishing them here, seeing the different consistency, how do they keep their shape, that kind of thing. Figure out all the different ways you can compare the two and see how they're similar and how they're different. Science. You can try for different results by using things like a different brand of glue, clear glue, or using contact solution instead. These things don't have to be overly complicated. It's just a matter of investigation. Design your own experiments safely and make connections. What more can you figure out about this experiment? How can you make it better and prove yourself wrong or prove yourself right? For the next few months, I'll be focusing on phenomena and experiments that you can do from your home, as well as some things that will be demonstrations, so science can be easier to do from home. Just because something is challenging doesn't mean it has to be scary. Just break it down into small pieces and let those little pieces build on each other and understand a little bit at a time. Science is based off of investigation, and if you understand the scientific process and how to document your data and to come to conclusions and to make connections, you can do really well in science. It doesn't have to be scary. Oh, I've been skewered. I have a light blue flavor. Ooh, it pops. I like it.